Hello and welcome to the 3D Amateur channel. Today we're going to be designing a mount for the TP-Link C200 smart camera, and we're going to do that in Tinkercad. This was a request from a friend and he wanted a mount for it to sit on his windowsill that will give him some height adjustability and some tilt functionality. Now looking online we have found a couple that offer the height but not the tilt. So let me throw up my sketchbook on the screen here and you can see we went through a couple of iterations of designing to try and figure out how we were going to do it. Now my first design, as you can see here, was a ball and socket joint with a screw thread in the ball and sockets that would enable the height adjustment and the tilt adjustment all in one ideally simple solution. But it turns out that 3D printing screw threads is not the easiest thing in the world, and for the size that we're looking, it's going to be quite weak with PLA. So I decided to abandon this idea and go with a scissor lift. After looking online, I found this, and it's a scientific lab jack. Now this is ideal for what we need. So it has a height adjustment from 45mm to 150mm, whereas we need from about 5mm to 100mm. So this is perfect and it's within that range. However, it doesn't have the tilt functionality. Now I was given two options here. I could purchase this and design a top plate for it that enabled the hinge functionality, or just go full on and design. And as this is a channel about me learning 3D design, I thought I would design everything. Although we are going to take the ideas from here and we're going to implement them in our own way. So the camera we're designing for is this one here, which is the TP-Link Tapo C200, as I said. And as you can see, it can be mounted upside down, on a wall, or however you want to mount it. And the way that this works is it has a base plate that has a bayonet fitting on it that the camera attaches to, and it has two screw holes so you can attach it to a wall. So if we return to the sketchbook, you'll see that what I did was got the measurements from that, and I've measured out the size of what I want it to be, and that center circle is the size of that base plate, with the two screw holes slightly offset, so when the camera attaches to it, it is centered. And what we're going to do is we're going to have a simple base, which I've already designed in Tinkercad, and then we're going to design the top that has a functionality where it's going to have two hinges at the top here, and it's going to have two screw threads here, and as you can see from this little diagram here, they're going to go through, they're going to rub against the base inside, and it's going to create that tilt functionality. So here we are in Tinkercad, and you can see my Aperture Science logo designs, but we'll save that for another video. And you can see my first iterations of the ball and socket joint with the screw thread. Now the ball and socket work perfectly, but the width of this and this was way too small to be able to be effective and hold up any weight, and was very weak indeed. So the first test prints I did of the ball and sockets and the screws did not go to plan, and everything broke. And the screw thread didn't work because it was too tight, a whole host of issues. So I abandoned that idea and we started on this one. So if I load this up, so you can see here my design for the base, which is very similar to the labjack stand that we just saw on Amazon, and it has the sliding hole here, circular hole here, and the arms. I've left this one open so I can show you how I designed these, which is very simple, just using primitive shapes, and I can give you a quick example of that if I ungroup these. So if we ungroup all of this, you can see there's various primitive shapes in here and other primitive shapes that we've set as holes. So Tinkercad is very simple to use in this respect. So if I group these together again, using the group function at the top here, you'll see they become one object. And that's the basic design process. I've tried to keep everything as simple as possible and using primitives and some very basic holes, as you can see here. So if we group these together, you'll see that they then become one object with the holes exactly where we need them. I've designed this around the M3 screws. I have quite a lot of them from another project that I was doing, so I've tried to design it in such a way that I use M3 screws for almost everything except the bit that allows it to extend. So that's what these are here. So we have one of these that's going to go through here and it's going to attach to here, and there's going to be on the outside a washer and a M3 screw, sorry. That will then screw into here and hold that tight, and we'll have exactly the same on the opposite end. And then the smaller ones are to go in here to do the exact same thing. Future me here, just jumping into the video to point out that this system didn't actually work. The axles on the left of the screen there don't really work at all. They were too small because I keep forgetting what scale I'm working in, and they were just too flimsy to hold any weight. So I did redesign another system that fits in place of that, and we will see that at the end of the video in the final assembly, so stay tuned for that. And now back to the video. So once this is all connected, we'll then have the scissor function, and now we just really need to design the top. But before we do that, I'm going to save these files. So there, save these files as STLs to make it easy to print. So to do that, really simply we'll select the item that we want, because I don't want to print all of these as in one go. So we're going to select that, and we're going to go to export. Hit STL, and then it will download it as an STL file. Then we can select one of the arms, and we'll do the same thing, export as STL. Now you can export all of these in one go, but as I've been designing different things on the same work plane, I want them all to be separate. And then we'll do the same thing with these two here. So we'll export that as an STL, and then we can export that as an STL. Let's get designing the top. So I've opened a new project in Tinkercad, and now we're going to design the top. Now the simplest way I can think of doing this is we're going to take the top that we just exported, import it again, and now we're going to create a hole, and we're going to completely cover the bottom half of that, group them together, and export this as an object. So that will be our top. And then what we'll do is we'll design a very simple plate with a hinge, and then we'll attach that after the fact when we go through assembly. So there we have it. That is the final design for the hinged top. We're going to have the hinges here, and this is going to rotate that way. Oh, keep me doing that. And raise up. And the way it's going to raise up is by using a M6 nut in here with an M6 bolt in there, and that's going to screw upwards into this plate here. Well, not into, but onto. And then that should support it enough with the additional supports here and here to be able to raise it just by that little bit. So hopefully that should all work. I don't see any reason why it wouldn't, but just to be sure, what we're going to do is we're going to test print this little section here and see whether it works. So to do that, I just need to extract that from everything else, save it as an STL file, and then we'll do a quick print. Okay, that seems to have worked. Let's poke out these holes, get a nut in there and see whether it actually manages to... Oh, there we go. Yeah, poke out them supports and see if it works. Okay, so supports are out. It does just about fit. You do have to screw it, but it does just about fit a 6mm bolt. So that is good. Let's get a nut in there and hopefully it will work if the camera decides to focus. Oh, that's a little bit of a tight fit. Oh, look at that. Beautiful. Right, and then screw. Ooh. Oh, that's a bit tough on the old hand tightening. And there we go. We're able to tighten the bolt. That should work perfectly. Okay, so after that successful test print, there's only one thing left to do, and that is to put the mounting system for the camera into the other side of this. So a bit of a long-winded way of doing it, but I've managed to offset them by 22.5 degrees. We've got two 3mm holes that the base will screw through, and this is now all measured out correctly. So it's just a case of getting this printed. Now I think I'm going to have to print it with this side down, even though that will mean I will need to put some supports in underneath here. But that shouldn't be too much of a problem. Everything else should print fine. And same with this one. It's going to have a couple of supports, but otherwise should print fine. The last thing we need to design is the holder for the screw thread. So if I come back to here, so this piece here, that's going to hold the screw thread in there. And if we have a look from a different angle, you can see there it's going to pull them together. So what we need is for this one to screw in and for this one to pull. So that's going to be a bit more of an interesting design on how we're going to do this. So what we need to do is, as we screw this, it pulls that bit towards it. We're going to use M6 spacing again for this. So let's head back to Tinkercad and let's get designing. Okay, so what we've designed here is two bars to go between the holes here in the center. They both have 6mm holes in the sides, so we can use a 6mm bolt to connect them. And then one of them's got a 7mm hole, so it should be able to slide straight through. The bolt should. And then the other one has a 6mm hole, but also with a space for a nut. So this one will be the one that pulls, and it will slide through here. So this should all work together, just like we have on here. So as this rotates, it's going to pull that one, and we're going to have the end resting on here. So we'll probably need to create somewhere for the bolt to actually rest as well. So let's do that. Okay, so I think we are actually ready to save and print, and then hopefully, if everything prints correctly, time to assemble. Okay, so we've got a new Tinkercad file open, and the last thing to design is the adjustment knobs for the elevation. and the adjustment knobs for the tilt. And then we'll be ready to print. So I think we're done. I've designed some very basic knobs that are going to press fit onto the end of the bolts. So we've got a smaller one here, which I'm going to print twice for the adjustments for the tilt. And then I've got a bigger one here that is going to be for the adjustments for the height. So let's get these saved, and then I think we are finally ready to start printing. So here we are finally in Cura, and we're going to import all the files and get them ready to print. So we're finally at the assembly process. Now there were a few trials and tribulations through the printing process and test fittings that I did, and this was one of them. So this was the original base plate, and this is 20mm tall, but once I fully assembled it, the entire assembly was 5.7 centimeters or 57mm, and ideally we needed to get it down to 50. So with this being half almost solid, I was able to take that additional 0.7 off of that base. So we ended up with a thinner base, but functionality wise it's still the same. One of the annoying things about this, however, was the first print I did, which I've stopped halfway through. I didn't realise that I had warping on one of the corners until, well, quite far into the print. So that was a bit of a fail and a waste of, that was about 7 hours worth of printing. So yeah, good fun. But we have our base. So let's pop that there. Then we had our original top plate or top frame. This again seemed to be perfect with the exception of one thing. These holes here, they would fit the arms perfectly, but I added these plates in to press against when we did the tilt function. And because of that, when you look through the holes here, they are actually pressed up against it. So when we got one of the arms in, it wouldn't actually fit. It wouldn't create a hole through there. So I had to redesign that, which is what I did with this one. And again, seemed perfect. The holes all lined up. We had, yep, perfected the holes. It was perfectly fine until I decided to assemble it. When you do a scissor lift, obviously the idea is that this stays flat, but because these holes here and here were actually directly opposite each other, what this meant was that the scissor lift didn't fit because the arms were offset. So if I bring a couple of the arms in, so when you do a scissor lift, obviously they go like that, which means they're offset. And if we pop this in here, that's perfectly fine, but then the offset one wouldn't fit into there. So I had to redesign it again, and that is what this one is here. So this was the final design. I also didn't realise how hinges work, so I've had to create some little indents in here for the hinges to work with the top plate. So the top plate we have, let me get rid of that one. So the top plate we have here was pretty much the final design. I didn't really need to do anything to change this. I've tidied it up a little bit. There was a few little misprints, which is why it's not great printing with supports. But I did need to use a Dremel to trim this edge here. So unfortunately that's not the prettiest because you can start to see some of the infill, but once we have it on, it works fine. So again, even though I had done the indents in here, initially that didn't clip together, but now it does perfectly. So we have our top with our hinge, we have our base, and we have 8 arms. So these will all be connected together in a scissor lift functionality there. We then have our knob for the height adjustment, which will attach to that bolt there, and then that will go through here and it will attach to this one here, which I had redesigned slightly with the end here so that we can put a 6mm nut, which I can't get out the box, into here, and then that will screw into there and that will pull these two together, which will create the scissor lift action. Then we have our 2 height adjustment knobs, and the way that these will work is we have a 40mm M6 bolt that these will attach onto the end of. Should be quite a nice press fit, but I am going to glue these together as well. And then that will go into here with another 6mm bolt, which should press fit into here. There we go. So once that's in there, that'll screw into there, and this will create that height adjustment. So the way that that'll work is that'll screw in, and when we've got the hinges in here, do it this way around so you can see, that will then keep pushing that down and give us our tilt. So we've got 2 of them for stability, and then the final piece is all of the little nuts and bolts that we're going to need to assemble everything. So rather than suffering through my voice, I'll do a time lapse of all of this and I will see you on the other side. And there we go. It is fully assembled, and hopefully you can see the way that this should work now. So we have this little thread will tighten here, which pushes against here, and then what that'll do is as that tightens, that will extend the scissor lift. And the way that that works, so let me get it to maximum height. So the way that that works is by pulling on the nut that's in here and just pressure fitting against there. And then that will pull them 2 legs together, which raises the scissor lift. So then the other functionality was the tilt, which we've got 2 panel pins in here, which act as hinges. So that can then move up and down freely. And then as you screw in these threads here, they then push that up to create that tilt functionality. So the last thing to fit, which is what these bolts and everything here are for, is the actual mount for the camera itself. So if I just lower this all back down, there we go. And then this is the bayonet fitting that I was referring to. And what I've done is I've made this circle just tight enough for it to pressure fit, so you don't have to use the bolts if you don't want to. but that will pressure fit into there. And then if you are going to use the bolts, it's just a case of a washer and a bolt in this one, and a washer and a bolt in this hole here. And then just to secure them on the other side, you can affix a small nut. And this will still give enough clearance for the camera to attach. So if I tighten that up, so it doesn't need to be particularly tight, it's just more of hand tighten. And there we go. And then the camera itself has the bayonet fitting on the bottom there. So we need to make sure that the DC plug is towards the back. And then that will clip onto there. And there we go. We have a fully secure camera. And now when you, that way, you can adjust that height and you can adjust the tilt. So let's see if it carries the weight. Which it absolutely does. And then hopefully with the base being a little bit lighter, when this is at full tilt, it shouldn't tip over. And full tilt is about 20 degrees, so if we screw that one all the way in, and then screw this one all the way in, which takes a little while. We then have full tilt. And there we go. So hopefully that should work for my friend's use. The total height when fully closed is now 5mm. And we have up to 20 degrees of tilt, which should hopefully solve his issue and be able to get the camera exactly where he needs it to be. So thank you very much for watching. Hope you've enjoyed this journey with me while I've learnt and failed to design various pieces for this model that has been a bit of a waste of plastic, but it is the way it is. It's all a learning process, and if you enjoyed seeing that, then by all means hit that subscribe button, give a like to the video, and comment down below. Would you have seen any of these mistakes before I made them, like with the hinges, or you know, with the silly little things like the extra hole height here? What's your process for designing a 3D part? Do you test it in software, or do you print out smaller versions and test them? Let me know in the comments below. Thank you very much for watching. I hope you have a nice day, and I'll see you again next time.